Welcome to SS2 Further Mathematics, Term 3, Week 14. Hypothesis testing is a formal statistical procedure for making decisions about populations based on sample data. It is the backbone of scientific experimentation, quality control, medical trials, and social research. By the end of this lesson, you will define null and alternative hypotheses, explain type 1 and type 2 errors, perform one-sample z-test and t-test, interpret p-values and critical regions, and answer WAEC Further Mathematics examination questions. Let us begin. Statistical hypothesis testing follows a structured procedure. Step 1. State the hypothesis. Null hypothesis H, a specific statement about the population parameter, usually the status quo or no affect. Alternative hypothesis H, or H the statement we want to test for evidence of. The null hypothesis is the one we assume true until there is sufficient evidence against it, like the presumption of innocence in a trial. One-tailed test, H specifies a direction, e.g. mu, mu or mu, mu. Two-tailed test, H says the parameter has changed without specifying direction, e.g. mu is not equal to mu. Step 2. Choose the significance level alpha, the probability of rejecting H when it is actually true, type 1 error. Common values, alpha equals 0.05, 5%, alpha equals 0.01, 1%, alpha equals 0.10, 10%. Step 3. Identify the test statistic, the quantity computed from the sample data whose distribution is known under H. Step 4. Find the critical region, the rejection region, the range of test statistic values for which H would be rejected. For two-tailed test at 5% level, critical region is z minus 1.96 or z greater than 1.96, total 5% in tails. Step 5. Compute the test statistic from sample data. Step 6. Decision. If test statistic falls in the critical region, reject H, otherwise, fail to reject H. Step 7. Conclusion. State the conclusion in context. Two types of error are possible in hypothesis testing. Type 1 error, false positive reject H when H is actually true. The probability of a type 1 error equals significance level alpha. Type 2 error, false negative fail to reject H when H is actually false. The probability of a type 2 error is denoted beta, power of a test equals 1, beta equals probability of correctly rejecting a false H. The ideal test has high power and low alpha, but these are in tension. Decreasing alpha, requiring more evidence to reject H, increases beta, makes it harder to detect a false H. We can reduce both errors by increasing the sample size and medical testing context, important for understanding HIV test. H, patient is HIV negative. Type 1 error, false positive test says positive when patient is actually negative, psychological harm, further unnecessary test. Type 2 error, false negative test says negative when patient is actually positive, patient unknowingly spreads HIV. Both errors are serious but in different ways. The clinical consequences determine which error is more important to minimize, guiding choice of alpha. The p-value, the probability of observing a test statistic as extreme as, or more extreme than, the actual value, assuming H is true. If p-value alpha, reject H, the result is statistically significant. If p-value greater than or equal to alpha, fail to reject H, insufficient evidence. The p-value is not the probability that H is true, a common misconception. The one-sample z-test is used when we are testing the population mean mu, the population standard deviation sigma is known, the sample size n is large, n greater than or equal to 30, or the population is normally distributed. Test statistic, z equals x, mu, / sigma / square root n, where x equals sample mean, mu equals hypothesis population mean, from H, sigma equals population standard deviation, n equals sample size. The standard error of the mean is sigma / square root n. This measures how much the sample mean is expected to vary from the true mean. Worked example, a manufacturing company claims its boats have a mean diameter of 10 mm with sigma equals 0.5 mm. A quality inspector samples 36 boats and finds a mean of 10.15 mm. Test the claim at the 5% significance level, two-tailed. H, mu equals 10 mm. H, mu is not equal to 10 mm, two-tailed. Alpha equals 0.05, critical region, Z minus 1.96 or Z greater than 1.96. Test statistic, Z equals 10.15 to 10, forward slash or 0.5 slash square root 36 equals 0.15 slash 0.5 slash 6 equals 0.15 divided by 0.0833 is equal to 1.80. Decision, 1.80 is not in the critical region, 1.80 less than 1.96. Failed to reject H. Conclusion, there is insufficient evidence at the 5% level to conclude that the mean diameter differs from 10 mm. Note, if we had used alpha equals 0.10, two-tailed, critical region would be Z greater than 1.645, 1.80 greater than 1.645. We would reject H at 10% but not at 5%, showing that conclusion depends on significance level. The one-sample t-test is used when sigma is unknown and estimated from the sample. Test statistic, t equals x, mu, forward slash, s slash square root n, where s equals sample standard deviation. Under H, t follows a t-distribution with n, 1 degrees of freedom. The t-distribution is similar to the normal but with heavier tails, accounting for the additional uncertainty of estimating sigma. As n infinity, the t-distribution approaches the standard normal. Critical values come from t-tables, specifying degrees of freedom, df equals n, 1, and alpha. For small samples, n less than 30 must use t-test if sigma is unknown, also requires the population to be approximately normal. Worked example, a sample of 10 measurements gives x equals 23.5 and s equals 2.8. Test H, mu equals 25 against H, mu less than 25, one-tailed left, at 5% level. T equals 23.5 to 25, forward slash, 2.8 slash square root 10 equals, dash 1.5, forward slash, 2.8 slash 3.162 equals minus 1.5 divided by 0.885 is equal to minus 1.695, df equals 9, one-tailed critical value at 5% from t-table, t.5. 9 equals minus 1.833. Decision, minus 1.695 greater than minus 1.833. The test statistic does not fall in the critical region, left tail. Failed to reject H. Conclusion, insufficient evidence that the mean is less than 25 at 5% level. Key points, hypothesis testing, formal procedure for making decisions using sample data. H. Null hypothesis, the status quo, assume true unless sufficient evidence against. H. Alternative, what we are testing for. Type 1 error, reject H when true, probability equals alpha, significance level. Type 2 error, fail to reject H when false, probability equals beta, power equals 1, beta, p-value, probability of observed, or more extreme, result under H, reject H if p alpha. One sample z-test, z equals x, mu, forward slash, sigma slash square root n, use when sigma known or enlarge. Critical regions, two-tailed, 5% z greater than 1.96, one-tailed, 5% z greater than 1.645 or z minus 1.645. One sample t-test, t equals x, mu, forward slash, s slash square root n, use when sigma unknown, df equals n1. WAEC test on hypothesis testing, state H and H clearly, choose significance level and state critical region, compute test statistic, make decision, state conclusion in context.